Hello, dear friends. Today I will discuss about hypothesis testing. So, how to arrive at null hypothesis, alternate hypothesis, how to calculate the critical values, then do the test statistics and determine whether to reject or accept the null hypothesis. So, let us start. So, what is a null hypothesis? That's our first question. Null hypothesis. Usually, null hypothesis are represented by H naught. H naught, this H naught will be the null hypothesis. One thing, it maintains status quo. That means whatever we were following for long, that will be the null hypothesis. Usually, every time it will have an equal to, either full equal to or greater than or equal to or less than or equal to. Some equal to sign will be there and status quo, it will maintain status quo. So that is about the null hypothesis. An alternate hypothesis will be the opposite of that. We are represented by HA or H1, and it will be opposite. So it will be either not equal to, less than, or greater than. Okay, so this is the alternate hypothesis. So one important thing is that in this hypothesis that you will be given an alpha value. If it is not given, or we will take it as 0.05, or sometimes it gives 0.01. Okay, so this is the level of significance. So its opposite is confidence level. So it is the 1 minus alpha value. Is the 1 minus alpha value gives you the confidence level. Confidence level. Okay. So one simple thing I'll tell you. You do so many tests and you will get some p value. Okay, p value. You do some t-test, you do some chi-square test, you do some f-test, anything. You do it and you get a p-value. One simple thing you can keep in your mind is that if the p-value is less than, p-value is less than alpha, you reject null hypothesis. This is the basics. Okay. So that thing you keep in your mind. After doing any test, you get a p-value. If the p-value is less than alpha value, you reject the null hypothesis. Okay. How? So one scenario is that you can keep in your mind. I'll tell you about that. I told that in the class also. Suppose you have got a coin. There's a coin with me. I am telling you it is a fair coin. So H naught is fair coin. My coin is fair coin. Okay. Alternate is, it's a tricky coin. Okay. This is my null hypothesis. So first time I am tossing. Okay. I got a tail. One tail. So what will be the probability of that? 1 by 2, that is 0.5. Okay, that is over. So what you will say, it's a good coin. There's no doubt about that. Next time I am tossing it 2 times. Okay, and both the time I am telling it's a tail has come. So it is 1 by 4. 1 by 4. 0.25. How the 1 by 4 is a probability? That is number of occurrence, the 2 times tail can come by total number of occurrence. So how is that? 2 times h, 2 times head, 1 time head, 1 time tail, 1 time tail, 1 time heads, and 2 time tail. Okay, so how you got 1 by 4? Only 1 time 2 times tail can come, and total number is 4, so it is 1 by 4. Okay, so like that you got 0.25, and that experiment is over. Now I am tossing it 3 times, and I am telling you all the 3 times I got tail. So what is the value? 1 by 8. Okay, so it comes to 0.125. Okay, 0.125. Same way. Okay, it is 3 times you are tossing, that is 2 raised to 3 will come, and 1 time all tail, 1 divided by 2 raised to 3. That is why how it 1 by 8. So that has been also over. So now I am toss. So that is all. So I am going to toss it for. I am going to toss it 4 times, and I am going to tell you. I am going to toss it 4 times. 4, and I am telling you it has come continuously tails. So that is 1 by 2 raised to 4. That is 1 by 16. That is equal to 0.0625. Okay, so that experiment is also getting over. Okay, that is I toss 4 times, and I'm getting I'm tossing the coin 4 times, and I'm getting the value as 0.0625. So now what you will be feeling? Yeah, some problem is with the coin, otherwise you will not get continuously 4 tails. Okay, still we'll give a chance. So again I am tossing it 5 times, and I am telling you all the 5 times I got tails. Okay, I'm telling you I got tails. So it is 1 by 32, that is 2 raised to 5, equal to, I mean 1 by 2 raised to 5. Okay, 1 by 32 equal to 0.3125. Okay, so then you are in your mind, you are sure that it is not a good coin, it's not a fair coin, not a fair coin, is it not? You people will surely feel, if I toss it 5 times, and all the 5 times I will never get tails, not a fair coin. So how it came to your mind, and you relate that your alpha value was 0.05. Okay, and now here comes for the 5 times tail, you got 0.03125. Okay, so it will be this alpha is less, this alpha value, the p value you got, this one is less than the alpha value. 0.03125 is less than less than 0.05. Okay, so this is, so as the p value you're going, so next time I'm tossing it 6 times, and then again I will get the half of this one. So if I get 6 times tail, you're sure, so the p value is going down. So as the p value goes down, the value you get, okay, the value you get, but okay, this value you get, as it goes down, okay, your belief gets bad or belief gets wrong. What was the belief? Your fair coin, status quo. Okay, null hypothesis was status quo, that is fair coin. That is wrong, fair coin. So after everything, what I'm telling you is that I'm deleting everything. Okay, I'm deleting. So what I'll close this, I'll take a new one. what I am telling you is that if the p value you are getting, okay, p value or probability value you are getting is very low, means very low, or less than alpha value, you reject null hypothesis. Okay, so this is the main thing. P value very low means you reject the null hypothesis. Okay, keep that in mind. You do some test, something you do, and you get a p value. You compare that p value with the alpha. That is it. Okay, if the p value is greater than alpha, you fail to reject or you accept the null hypothesis. Okay, so we'll do a test. It's a two-sided test. Suppose a pharmaceutical company manufactures one pill. They need to perform some quality assurance to ensure that the correct dosage, which is supposed to be 500 milligrams. This is a two-sided test because if the company pills are deviating significantly in either direction, meaning there are more than 500 milligrams or less than 500 milligrams, this will indicate a problem. So what is the, so let us do that. So what is the null hypothesis? Null hypothesis is mu equal to 500 mg and HA, alternate hypothesis, mu not equal to 500 mg. Okay, so that is a null and alternate hypothesis. Okay, clear? So we have defined our null hypothesis and the alternate hypothesis. So next what? So they had told in a random sample of 125 pills, there is an average dose of 499.3 milligrams with a standard deviation of 6 milligrams. Okay. So here what is it? So they had given mu equal to, let us do that. Mu equal to 500 grams, 500 milligrams, S bar as 499.3 milligram and standard deviation as 6 milligram. Okay, and let us take alpha equal to 0.05. So here what we have to do now, we have to find the Z value corresponding to alpha or p value. Okay, so and then Z value, because p value is given 0.0, alpha is 0.05 means other side it will be 0.95. Okay, 1 minus alpha 0.95. So how you can find the Z score? Z score is, what is Z score? Z score equal to 499.3 minus 500 divided by 6 by root 125. You get a value. Okay, and then you use that to see whether it is lying in the rejection region or not. So our Z corresponding, to find the Z value corresponding to 0.05. Okay, Let us try that. So first we'll find the Z value corresponding to 0.05. We'll take an Excel equal to norm dot f dot inverse 0.05. It is minus 1.64485 and same norm dot s dot inverse 0.95. Two tail. Okay. So now what has happened now? Let us calculate our Z from the Z equal to what is it? 499.3. 499.3 minus 500 divided by 6 divided by square root of how much? Square root of 125. 125. So this is the Z value you got. Okay. So whether this Z value is in the rejection region, let us draw and see. Okay. So now what you got is that your normal distribution 500 mg. From the alpha value you got Z as minus 1.644 and here also 1.644, and from the test statistics we got is minus 1.3, so it will come around minus 1 point. Okay, minus 1.3. So this is not lying in the critical region. Okay. Yeah, I think I made a mistake here. It is a two-tailed test, and then just we'll try that also. Here we did a mistake. We had to divide it by 2, as I always tell you. Yeah, it is a little more far. No issues. One minus 0.05 divided by 2. Okay, still it will go far only. So no issue. So here this value is not lying in the critical region. So what will we do? We'll reject the. We'll accept the null hypothesis. Okay. So here we will accept. So the Z value we got, what we got, Z value what we got is near Z minus 1.3 something, and from the critical value Z we got is that something minus 1.9 something. Okay, so we failed to reject. We failed to reject. That's answer. Failed to reject. Okay. So one more method we'll try. So we got the Z value. Okay. And then whether we can. So how to use the Z table and then find. Let us see that. So we got a Z value. What is the Z value we got? We got an Z value of minus 1.3. So corresponding to this, let us see what will be the p value. Norm dot s dot this comma 2. 0.09653. So this is larger than 0.05. Okay, so we cannot reject the null hypothesis because the alpha value, which is 0.05, is less than this value. Okay, so let us see how you can do the how you can test it using a Z table. So Z table, there is a left column is there, right column is there. So left column shows the 10th value. So whatever the value minus 1, whatever value minus 1.30 minus 1.3. So you can see this value. So the same minus this value. Okay, we got the same value minus 0.9680. That is the value 0.9680. That's what we got here. Okay, so the p-value what you got is 0.096053, 0.096, yeah, 0.096. So it is bigger than. So this is how you have to use the Z table. First, if you get a Z value, this gives the minus 1.3 means that the 10th place, and this is the 0 is 100 minus 1.30. So you have to take this one. This is how you use the Z table. And now suppose it is positive Z means what you'll do, you have to multiply this into 2 times and then take that. Okay, that is the that is what you have to do. So this is how you, this is a method how you can use the Z table and then find the p-value. Same way you are how you did in the Excel. Okay, so one more, this is for the left tail test that I took in the class. This you try to do it as an assignment. So how you can do this, you have to find the null hypothesis and alternate hypothesis. So here the null hypothesis will be mu is greater than or equal to 3262. Okay, greater than or equal to 3262. We can just I'll just write it down, and mu will be greater than or equal to 3262, and null hypothesis will be mu less than 3262. Okay, so now your alpha is given as 0.05. So it is less than 3262. So it is a left tail test, left tail. So corresponding to this alpha equal to 0.05, you get Z equal to minus 1.65, minus 1.65. Okay, so this is your critical value, Z equal to minus 1.65. Okay, so now you calculate your Z score. Z score you have to calculate, that is 2995 minus 3262 divided by 50, divided by what is standard deviation? 1100 divided by square root of 50. Okay, and you see whether your this Z value is less than or greater than minus. So you draw a normal distribution and you got a minus 1.65. You can just verify this comes to minus 1.72, minus 1.72. So this minus 1.72 is lying in the critical rejection region. Okay, this is a rejection region. Okay, so you reject the null hypothesis minus 1.72. So you reject the null hypothesis. Okay, so this is how you do. Okay, and you can take the p-value corresponding to the minus 1.72. Let us, what is the p-value? P-value corresponding to norm dot corresponding minus 1.72 comma 2, 0.042. Okay, that is minus 0.42 is less than 0.05. Okay, 0.042716. So I am telling you two methods. One is you said your set score was lying in the rejection region. Okay, and I forgot to close it, that's right. Okay, so anyway, so I got it. So before we calculate the Z value and you got it as minus 1.7 is less than minus 1.65, and now corresponding to the minus 1.7 you got the p-value as 0.0427, which is less than 0.05 again. So same in this method also you get a p-value less, so you reject the null hypothesis. Okay, hope this is clear to you. These are the two methods, so just try some questions yourself and